Hello and welcome to the channel. Today we are doing a deep dive into one of the most talked about yet least understood experimental compounds in resistance training, ACE-031. You've probably heard whispers about it on forums or seen it listed on peptide sites. But what does the actual science say? By the end of this video, you will understand exactly how it works, what the human data shows, and why this compound was ultimately abandoned by its own developers. Let's get into it. ACE-031 is the investigational code name for a soluble recombinant fusion protein. To break that jargon down, it's a lab-made decoy receptor. Specifically, it's the extracellular portion of the human activin receptor type 2B, or ACTR2B, fused to the Fc region of human immunoglobulin G1, written IgG1. Why does this matter? Because this engineered protein acts as a ligand trap. It floats through the bloodstream, binding and neutralizing a family of proteins that naturally put the brakes on muscle growth. The most famous of these is myostatin. But it also mops up activin A, GDF11, and other related ligands. To understand why this is powerful, you need to zoom in on the mechanism of action. This section is the conceptual core of the whole video. Inside your body, your muscle cells produce a protein called myostatin. Think of it as a natural check on muscle growth. It's a member of TGF-beta superfamily, and its job is to bind to the activin receptor 2B on the surface of muscle cell. When it does, it triggers a signaling cascade inside the cell that ultimately suppresses protein synthesis and inhibits muscle fiber formation. In simple terms, myostatin tells your muscles that's enough. Stop growing. ACE-031 short circuits this entire system because it's a soluble copy of the activin receptor 2B. So, it intercepts myostatin and related ligands in the bloodstream before they ever reach the real receptor on the muscle cell surface. The ligands bind to the decoy instead of real receptor. So, the inhibitory signal never gets through. The brakes come off. What makes it uniquely interesting compared to drugs that only block myostatin is that it captures multiple negative regulators simultaneously. Myostatin, activin A, activin B, and GDF11. This broad spectrum inhibition means the anabolic signal is amplified across more pathways than myostatin blockade alone. Furthermore, research published in the Journal of Applied Physiology demonstrated that it increases muscle mass independent of fiber type. This is distinct from selective myostatin inhibition, which predominantly targets fast-twitch type 2 fibers. With ACE-031, both type A, a slow twitch, and type 2, fast-twitch fibers undergo hypertrophy. In the plantaris muscle of mice, a predominantly fast-twitch muscle, mean fiber cross-sectional area increased by 57%. Let's move from mechanism to measurable outcomes. In a double-blind, placebo-controlled phase 1 study published in the journal Muscle and Nerve, 48 healthy postmenopausal women received a single subcutaneous dose of ACE-031 ranging from 200 to 3 mg per kilogram of body weight. The result at day 29 in the highest dose group were striking. A 3.3% increase in total body lean mass, measured by DEXA scan, with a p-value of 300, meaning it's aesthetically significant. A 5.1% increase in thigh muscle volume, measured by MRI, again with a p-value of 300. These are single-dose results, not a cycle, one injection. The study also noted aesthetically significant changes in serum biomarkers, suggesting improvements in bone formation and fat metabolism. It appears to shift body composition in a favorable direction: more muscle, stronger bones, and less fat. In a 14-week non-human primate study using common marmosets, ACE-031 administration produced significant increases in lean body mass compared to vehicle-treated controls. The biceps brachii muscle showed increased cross-sectional area in both type 1 and type 2 fibers, and ex vivo contractile testing revealed improved absolute and specific force production. In the Duchenne muscular dystrophy trial, researchers observed trends toward increased lean body mass, increased bone mineral density, and reduced fat mass. They also noted a trend for maintenance of the 6-minute walk test distance in ACE-031 treated boys while the placebo group declined, though this didn't reach statistical significance. This is where the story takes a critical turn. ACE-031 was not discontinued because it didn't work. It was discontinued because of side effects that emerged in the pediatric Duchenne muscular dystrophy trial. In that randomized, double-blind, placebo-controlled phase 2 study, ACE-031 was administered subcutaneously every 2 to 4 weeks to boys with DMD. The study was stopped after the second dosing regimen due to potential safety concerns. Specifically, Epistaxis, meaning nosebleeds, and Telangiectasias, which are dilated small blood vessels visible near the surface of skin. While it wasn't associated with serious or severe adverse events, these non-muscle related adverse events were significant enough that Acceleron Pharma, the company developing the drug, made the decision to discontinue the study and ultimately the entire program. In the healthy volunteer study, adverse events were generally mild and included injection site erythema, meaning redness at the injection site. But the pediatric data revealed a safety signal that raised concerns about the drug's effects on blood vessel integrity, likely related to the broad spectrum inhibition of TGF-beta family ligands beyond just myostatin. This is a crucial point. The very thing that makes ACE-031 so effective, its ability to block multiple ligands, may also be what makes it problematic. Myostatin is primarily a muscle regulator, but activin A and other ligands, ACE-031 captures, play roles in angiogenesis, meaning blood vessel formation, and tissue remodeling throughout the body. Now the half-life. This is one of its defining pharmacokinetic features because the Fc region of the fusion protein interacts with neonatal Fc receptors, or FcRn, on endothelial cells. The protein is recycled back into circulation rather than being degraded. This extends its serum half-life dramatically. In the phase 1 clinical study, the mean terminal half-life was measured at 10 to 15 days, following a single subcutaneous injection. Some sources, including preclinical primate data, suggest a half-life closer to 12 to 16 days. To put that in perspective, a single injection remains pharmacologically active in your body for approximately 2 weeks. This means infrequent dosing, once every 2 to 4 weeks, is sufficient to maintain ligand blockade, as was the dosing schedule used in the DMD trial. Its extended half-life makes it an attractive research tool for chronic, systemic applications. But it also means any adverse event, any adverse side effects will persist for an extended period after dosing ceases. A double-edged sword. I need to be very clear here. ACE-031 was never approved for human use. There are no established dosing guidelines for bodybuilding, athletics, or any non-medical purpose. Everything I'm about to share comes from the clinical trial protocols, and this is not a recommendation. In the phase 1 healthy volunteer study, a single subcutaneous dose ranging from 200 to 3 mg per kilogram was administered. The 3 mg per kilogram dose produced the most robust increases in lean mass and muscle volume. On the other side, in the DMD trial, it was administered subcutaneously every 2 to 4 weeks in an ascending dose design. The dosing regimen tested included 0.5 mg per kilogram every 4 weeks and 1 mg per kilogram every 2 weeks. The long half-life of 10 to 15 days reports infrequent dosing. A single injection maintains pharmacologically active levels for approximately 2 weeks, which is why a dosing interval of every 2 to 4 weeks was selected for clinical trials. Now, if someone were to consider using this compound in a research context, and again, I'm not endorsing this, the clinical data suggests that a cycle of approximately 8 weeks with a dose of 0.5 to 3 mg per kilogram every 2 weeks, that would theoretically maintain a steady state ligand inhibition. However, the long half-life also means that if adverse effects occur, they will persist for an extended period. The compound and its downstream effects on muscle signaling may remain active for weeks after the final dose. Furthermore, it's a biologic drug, not a simple peptide. It can't be synthesized using a standard solid-phase peptide synthesis. Producing a correctly folded, glycosylated 60 kilodalton fusion protein requires a mammalian cell expression system. The black market products sold as ACE-031 on peptide websites are almost certainly not authentic, as confirmed by analytical testing, a 2025 study published in Drug Testing and Analysis examined 14 black market products and found that none contained the correct intact fusion protein. Some contained fragments, some contained unrelated substances entirely. So, there you have it. ACE-031 is a soluble activin receptor type 2B decoy that produced measurable increases in lean body mass and muscle volume in human trials with a single dose. Its half-life of 10 to 15 days make it one of the longest acting myostatin inhibitors ever tested in humans. But the same broad-spectrum mechanism that makes it so powerful also introduced safety concerns that ultimately killed the clinical program. If you are interested in the science of muscle growth and the pharmacology behind these experimental compounds, hit that subscribe button. Drop any question in the comments, and I'll do my best to address them in future videos. Thanks for watching. I'll see you in the next one.